This is your introduction to electricity. All circuits need three things: source, load, and path. A source is a voltage supply, or energy. A load is something that's doing work for you. This can be a motor, a light, or a heater, for example. And a path is a way to get the source to the load and back to the source again. Very important, it must return to the source to complete the circuit. To explain these three things, we're going to use an analogy. We have a garden hose that's going to represent our piece of wire, and a small golf ball to represent the electron. We're going to take a bunch of these golf balls and fill the garden hose up from one end to the other. This is going to represent our piece of wire, which is filled with electrons from one end to the other. A piece of wire, for our example, is a good conductor. A conductor is any material that has a lot of free electrons in it willing to move around. Some examples of good conductors are copper, aluminum, and gold. These conductors allow what's called continuity, or a path for these electrons to move in. The opposite of a good conductor is an insulator. An insulator is any material that does not have a good path, or it doesn't conduct real well the flow of electrons. They do not have a lot of free electrons present to allow that flow. Some good examples of good insulators are rubber, glass, and air. For the first part of our example, we're going to hook up our source to our conductor. When we do this, the source tries to push an electron into the conductor. To visualize this, we're going to take our golf ball and push it into one end of the garden hose. When we do this, we have a domino effect, one golf ball bumping into the next one until one tries to come out the other side. This is what happens inside of the conductor. When we hook up our source, we push an electron into one end, we have a domino effect of electrons, and then one electron does try to come out the other end, ends up going back to the source. When we hook up a load, we are hooking up any device that can do work for us. This can be a light bulb, a motor, anything electrical that's trying to do work for us is a load. And a load exhibits some kind of resistance to that flow of electrons. We can measure the amount of resistance in a measurement called ohms. Ohms is the amount of resistance. The higher the resistance, the harder it is for that flow of electrons to get through the path. We can show this by just slightly pinching our garden hose, making it a little more difficult for those golf balls to go through. It will take a little bit more energy to push those through to complete the path. We can measure the intensity of our flow of electrons by measuring the current. Current is measured in amps. Amps is the amount of electron flow through our path. The higher our source, the more flow there will be. The less resistance, the more flow there will be. Let's recap. All circuits need three things: source, load, and path. Our source is our energy source, measured in volts. Our load is any device doing work for us and exhibits some kind of resistance to the circuit. We can measure the amount of resistance by measuring the ohms. And a path. A path provides a way for those electrons to flow from the source to the load and back to the source again. We can measure the amount of current flow, or flow of electrons, by using a unit of measurement called amps. Amps is the amount of current flow.